Hello guys, could you comment your names when you're here? Because I don't think anyone has so far. Cool. And then we'll get started. Okay, here we go. Cool. Right. So, um, so I've got Jolie. We've got Rob, Harry. Harry, you coming to this one instead then? Cool. Jasmine, Grace, Melissa, Jack, Jake, Finn. Yeah, that's fine. Molly and Elizabeth. Cool. So Ollie, Ed, Dan, Poppy, Emerald, and Don. Are any of you here? We will see. Right, what are we doing today? So we're going to try and finish off that stats mechanics paper. We might get it done in today's lecture. We'll see how things go. So the next question we were on is this one. Can you guys see it? Because I know the resolution's been a bit less good since I scaled things down. Can you guys read that, or do you want me to zoom in a bit more? I think I'm going to zoom in a little bit because that is a bit small. So does that make things a bit easier to see? That force it's cut off is 40 newtons. Cool. All right, so if you guys could start today by trying this one. It's an 8-mark question, so I'll give you 8 minutes to do it. Take care of it. There's a lot going on, especially in part A. You've got to do quite a few different things at once. But we've done quite a few of these now, so it should be all right. So 8 minutes starts from now. Comment if you need help, or if you've got an answer you want verifying. Cool. Right, guys. Let's go through this then. So yeah, Dan and Ollie and Dom, yeah, got you guys all ticked off as well, and Emerald as well. Cool. So we're just missing Poppy and Ed. So if you guys are here, send me an email because I can't see your comments. Right. So good. The mic is on. Everything. Yeah, good. All right. So wouldn't create a mass 20 is pull along straight line. Blah, blah, blah. Handle is inclined at the angle there. Tension 40. Coefficient of friction 0.14. So we're going to have some friction. So let's add some stuff to this diagram first of all. Friction there. Then we know mu is 0.14. Cool. Right. We want to find the acceleration of the crate. So first of all, we need to resolve vertically to find the reaction force. Let's make that a bit smaller so you guys can see it. And we're also going to have 20g down. So that's all our forces acting on this crate. Right, so if I resolve vertically upwards, we get R minus 20g plus 40 sine alpha equals 0. So we write that again a bit smaller. So R going upwards, 20 going down, so take it away. We've also got that 41. That 41 is acting upwards. It's pulling the box up a little bit. So plus 40 sine alpha equals 0. So R is 20g, take 40 sine alpha. Cool, we know tan alpha is 3/4, so if I draw a quick triangle, there's alpha, tan is 3/4, so it's a 3-4-5 triangle. So sine is going to be 3/5. So we can say that R equals 20g minus 40 lots of 3/5. So we can actually work out a numerical value for R. So 20g take away 40 lots of 3/5. So we get 172 for R. Cool. Right, so that's half of the problem. We now need to resolve horizontally to find out what the acceleration is. So if I get rid of everything so far, so I'll leave that down there. So we're now going to resolve horizontally. So, and we're resolving in the direction I think it's accelerating in. So we've got the tension 40 cos alpha minus the friction equals the mass 20 times the acceleration A. Now we know friction is mu times R. So 40, we also know cos alpha is going to be times 4/5 minus F, and F is 0.14 times R, which was 172. That's going to equal 20A. So we can multiply this out, 40 times 4 divided by 5. Take away 0.14 times 172. Gives me 7.92. And divide that by 20 to get an acceleration is 0.396 meters per second. So that should be your acceleration from this one. Cool. All right, let's make some space. So the crate is now pushed along the same floor using the handle. Let's just recap. Okay, so all right, the handle is that thing on the end. Okay, so we're now pushing it. Explain why the acceleration would now be less than the acceleration of the crate found in part A. All right, I'd like to have some replies to this. So could you guys have a think, see if you can write an explanation, short sentence. Why would the acceleration be less in the new situation compared to the top situation? And it's all to do with reaction forces and friction. So I'm going to give you guys 2 more minutes to try and write down what you think the reason is for that. So give that a go now. Oops, sorry guys, Ollie didn't see that. Yeah. So a couple of reasons then. So Elizabeth said bigger R, so bigger F, so smaller A. Yep, yep, that's right. Jack said that some of the thrust is going downwards. It adds to the friction. Yeah, so I reckon both of you together have got a good explanation there. So because here we go, we've got some more. The vertical component 40 is now acting down instead of up. Therefore, the size of the reaction will be greater. Therefore, the friction will also be greater. Yeah, that's good answer. Good answer there, Grace. Jasmine says the downwards component of the push will be another downwards force along with the friction. Therefore, A will be smaller. Close. I don't like how you said friction was downwards though. So basically, the idea behind this is you've got this force here. Some of the energy, some of the force there is pushing it into the ground. If you push it into the ground, that's going to cause your reaction force to increase. If your reaction force increases, remember F equals mu R, your friction is going to increase. So yeah, so we can say 40 now presses into the ground. Therefore, R increases. Therefore, F increases. Therefore, A decreases. Nice. So you can imagine the top example, we are pulling it up. So actually, we relieved some of the friction in the top case, and in the bottom case, we're pushing it down, so we made it worse. Yeah, cool. So cool. Yeah, that's that. Good. All right, next one. Let's just delete this. Ed, here, sorry for being late. Ed, can you just rewatch the rest of it? Try not to be late though, because you missed a whole question. Right, next one. So we've got some vectors with some calculus. So you guys normally hate these, so we'll see how we get on. 8 marks, differentiation, integration, and then part B is a suvat, I think. No, but all of this is suvat. This is all vector suvat, so no calculus at all. I was chatting rubbish. Vector suvat. See how you get on. It shouldn't be too bad. 8 marks, 8 minutes. I'll see you in a bit. All right, let's do this then. So yeah, it's a bit of Suvat really. Vector Suvat. So the first bit, um, we know our initial velocity u is 2 minus 3. We know when t equals 2, our position is 7 minus 10. We want to find a. So s equals ut plus half at squared. So we're going to say 7 minus 10 equals u 2 minus 3 times 2 plus half a times t squared. So we get that. So working this one out, say minus 710 equals 4 minus 6 plus 2a. So therefore 2a, so a equals the magnitude of a, square root 5.5 squared plus 8 squared. And square root, so we get what have I done wrong? Half at squared ut, yeah. Oh, I got the minuses wrong around, damn it. I have spotted it. So that should be minus 10, positive 7. Okay, easily done. Don't worry. Don't worry. Okay, so 7 take 4 is 3. 10 minus 10 minus 6 is going to be minus 4. Yeah. So we get A is 3 over 2. I minus 2j. So we need to do 3 over 2 squared and then 2 squared. Which gives me exactly 5 over 2. Cool. So that's how you do the first bit. Second bit then. So we want to try and find. Let's have a read of this one. Second one then. Yeah, we want to. We've got P leaving the point A, so we got to point A, which was 7 minus 10. Okay, and it had right. So the acceleration changes. So our new acceleration is for 8.8. And we want to find the time it takes to go from point A, so this is our origin point A, oops, to point B. And we know at point B, it the direction of motion is northeast, so the final velocity is lambda. North is up, east is that way, so it's going to be lambda 1, 1. Okie dokie, that's my acceleration. We want to find t. We need one more bit of information then. We don't know s. We're going to need to work out the velocity that we had then. So we need to work out our final velocity in part A, and then that's going to be what affects part B. So v is u plus at. I think is probably the best way about this. I wish I hadn't robbed out the other. What do we get? Let me rewind. Okay. So we'll do the first bit first, and then we'll come back to the bit in blue afterwards. So my final velocity is what we want. My initial velocity is 2 minus 3. We worked out the acceleration was 3 over 2 minus 2, and t is 2. So working that out, we're going to get 2 plus 3, so we're going to get v is 5, and then minus 4 plus minus 3 minus 7. Cool. Right, so we're going to use that as our initial velocity. So, and then we've got v equals u plus at again in this part of the question. The only difference is we now got to find lambda first. So v lambda 1 equals u plus a times t. And this is what we're trying to solve there. Equals 5 plus 40. And for the j coordinates, we get lambda is minus 7 plus 8.80. We can set those equal to each other because they're both equal to lambda. So we get 5 plus 40 equals minus 7 plus 8.80. So we get 4.8 t equals 12. So we get t equals, interesting, 2.5 again to go from A to B. Cool. Right, everyone okay with that? If so, let's move on. So we've got a couple of questions left in this paper. Okay, yeah, this looks a little bit more difficult. Can you guys see this is my first question? Because this is a lot smaller. Have like if you need me to enlarge it, I can. Yeah. Yeah, I reckon that's probably too small. See if I can fit it onto 2. Actually, I'm going to just draw the picture myself and then we've got all that extra space. So give me a sec here to copy this sketch. Cool. All right, if you guys could try this one then. So I think this is going to be quite a bit more difficult. We got a 13 mark question. So I'll give you guys 15 minutes for this one. Comment if you get stuck. Work through it carefully. Again, we got a rod attached to a or plank with mass and length attached against the wall. It's got it's got pivot on the wall and it's got a bit of rope attached to the plank. And then we've got a block of mass 3m placed on the plank. So be careful of all the forces involved, but you guys have done these before. So I want to say 15 minutes. Cool. Comments if you get stuck though, because I don't want you guys to be stuck there doing nothing for 15 minutes. All right, give it a go. Right, yeah, this one's pretty difficult. I've just finished it, but that took me what? How did I give you guys? 15 minutes? That took me, yeah, about 13 minutes is what you meant to get. If you guys do want a couple extra minutes, so you can do it if you want, but it won't count towards anything. Right, guys, I'm back. I have hiccups, so that's gonna be fun. And I put the mic on my head. I'm back. I have hiccups, so please excuse hiccup noises. This question was pretty horrible. That's my workings. Let's go through it, but yeah, wasn't the easiest. So I'm just trying to think what's the easiest way to do this. I know what might be nice. What might be nice and clever. Let's so we'll do it bit by bit using this to write on. Cool. Way better. Okay. So so for the first bit, we want to resolve moments about A. The reason I know we need to go about A is because I don't want to deal with the reaction force at A. So if we go about A, we don't have to worry about that reaction force. Cool. So we're gonna go about A. May as well go clockwise. So we're gonna get the weight of the mass of the beam. So we've got mg. We've also got the weight of the particle, and we've got tension going up there as well. So we've got mg times A plus 3mg times x, take away t well, t's there. It's going to be t sine alpha times 2a. And that should all equal 0. So what we need to do is rearrange this. Because tan is 3/4, again, similar to in the last question, it wasn't the last question, but similar to a question we did earlier. So, well, not, don't need to be that big. 3/4 is tan, so there we go for 5. So sine is going to be 3/5. So we get mga plus 3mgx minus 3/5. Let's change that and make it 6/5 of a t equals 0. We want to rearrange to get t, I think. Yep, we want to get t. So we're going to add that term to the other side. And I'll factorize these while we're there. So if I take out a factor of mg, we get 3x plus a equals 6/5 of at. Divide the other side by 6/5 a to get 5mg 3x plus a over 6a equals t. So that's how you do the first bit. Okay, next part. Okay, so now we're told the magnitude of the horizontal component is 2mg. So if I add this to I'll do another sketch quickly. We've got R there, which is our reaction force. And we've just been told the magnitude of the horizontal component, so we know this part is 2mg. So we can use that. We don't need to find R, we can just use the fact that we know the horizontal component. So what I want to do now is resolve horizontally. Because we've already got an expression for t. I'm going to make this a bit smaller here. So we've already got an expression for t, which was there. We can use that alongside r, because those are the only two horizontal forces I have to find x in terms of a. So we're going to resolve forces horizontally. So going in that direction, we got r, which is 2mg, minus my horizontal tension, which is going to be t cos alpha, and that should also be 0 because it's still in equilibrium. Okay, so 2mg stays the same. T cos alpha, well, cos alpha is 4/5, and t, we know it from earlier, is the thing I circled. So we're going to take away 4/5 of 5mg 3x plus a over 6a. And we want to rearrange this to get x in terms of a. So that will equal 0. I am going to divide everything by mg. So we'll cancel out the mg's there with the mg's there. And then just start rearranging it. So we get 2 minus 2/3 3x plus a over a. Can you see that? Nope. Yeah, that. Get myself out of the way as well. I'm over to the other side to get 2 equals 2 lots of 3x plus a over 3a. Times it to get 6a equals, expand the brackets to get 6x plus 2a. We want to get x, so I'm going to take 2a from each side to get 4a equals 6x. And divide by, 6a, 4a equals 6x. So therefore x equals 2/3 of a. Cool. Alright, so that's that part. Okay, next bit then I want to try and find tan of beta. And this is quite difficult. So we're told, again, if I resketch R from the wall there, we're trying to find this angle here, beta. Now I know horizontally the force was 2 mg. So if I can find the vertical force here, we can just use those two forces to find beta. So I'm going to resolve horizontally, and no, I'm not, because that won't work. I'm going to take moments now about point B, so that I can include the vertical component of R in my calculations. So, oh dear, there you go. Clockwise about B. So we're going to get R up times 2A minus MGA minus 3mg, and then the distance, remember the weight P was 2/3 of the distance between A and P. We're going to use, that's 2/3, the whole length is 2, so we're going to do 4/3 of A as our distance. Does that make sense? Sorry, I'm a bit hiccuping, so I'm distracted. If if this distance here is 2/3 A, then this distance here is 4/3 A. So that's why we're using 4/3 of A. There. Okay, so set that equal to 0, and then try and solve this. We get every term here has an A, so I'm going to cancel out all of the A's. So we get 2R up equals mg plus 4/3 times 3 is just 4mg. So we get that. So we get R up is 5mg. 2R up is 5mg, so R up is 2.5 mg. Okay, so we got upwards force on R is 5 mg. Sorry, 2/5 mg. 2.5 mg. Horizontally, we were told it's 2 mg, so I can use tan beta is 2.5 over 2, which is 1.25. So tan beta is 5 over 4. Cool. And the last bit is to try and explain so it says the rope will break if the tension exceeds 5 mg. How will that restrict where we put P? So we're going to resolve again, I think about R. So actually, no, we're not even going to do that. We're just going to look at our tension equation from earlier. So we came up with earlier. God, I'm making a right mess of this, aren't I? Get rid of that. Let's put this over here this time. I don't even need this anymore. Right, so we are going to use our tension equation from earlier. So that equals T. So we look at this one, and we know the tension cannot exceed 5. Okay, so 5 mg has to be greater than the equation here. Let's write that again, but better. So our tension must be less than 5 mg, is what I'm saying. So basically trying to solve this inequality to find what the restriction is on the positions of P. And remember, the positions of P is X. So we want to try and find X as a factor of A. So if I times up by 6A, we'll get 30 mga is greater than 5 mg 3x plus a. Cancel out mg on each side because we don't need it. And we can now expand those brackets. So we get, I'll divide both sides by 5 as well. So we're going to get 6a is greater than 3x plus a. Take a from each side, so we get 3x less than 5a. So x has to be less than 5/3 a. If x is any more than 5/3 a, then it will snap the tension, and yeah. Cool. Hope you're all okay with that one. That was a bit trickier. That took me quite a while as well, but yeah. Okay, next question then. And the last one, oh my god. So question 15. So this is a, 10, 15 marker again. And this is the projectiles question on this paper. Just checking to see if you guys can see. I think you can. Oh. Yeah, okay. So could you guys try this one? So you've got projectiles. It's a pretty bog standard projectiles question. Yeah, we've got that lovely 9 mark question in the middle. So give it a go. I'm going to try this one as well, and I'll be back in 15 minutes to go through this one in the last 5 minutes of the lecture. Cheers. Cheers, guys. Cool. Right. Yeah, it wasn't too bad. It was taxing, but yeah, it wasn't awful. Um, okay. Let's bring in some blank paper again so I can actually do stuff. Right, so for the first bit, we want to try and find u squared. Okay, and we need to use the information we've been given. All we've really been told so far is the max height is 3 meters. So we're just going to be resolving vertically. So we know the initial vertical velocity uv is going to be u sine alpha. We know the acceleration vertically is minus g. And we know the final point vertically is 3 meters above the ground, which is 1 meter above where we started. And we want to try and find the initial velocity. No, we know the final velocity is 0. So we want to rearrange and try and find an expression for u. So we're going to be using v squared is u squared plus 2as. So v squared 0 equals u squared sine squared alpha. V squared is u squared plus 2 minus 2a, which is g, and s is 1. So we get to that equation, rearrange it to get 2g equals u squared sine squared. Divide by sine squared to get u squared is 2g over sine squared alpha. So we get that, which is what they wanted us to show. So that's good. Right, part B. So we're told the final point we get to has a horizontal distance of 20. So we're going to be moving 20 across and a vertical height of 0.75. So we started at 2, so we're going to end up moving down by 1.25 meters. So that's our overall trajectory. So we want to try and find the size of angle alpha, and this is the 9 mark part of the question. So this is quite difficult. We need to resolve horizontally, vertically, and then combine it with the stuff we already did in part A. So I'm going to resolve horizontally first, I think. Yeah. So horizontally, we know our displacement is 20. We know A is 0. And we know U is U cos alpha. And then T is going to be T because T is the same in both equations. So if we resolve this, we're going to get S equals UT plus half AT squared. 20 equals UT cos alpha, and then nothing. So that's what we get for that one. Going to do the same thing again now, resolving vertically. I'm going to resolve vertically up. I always go up. So same idea. We've got S is minus 1.25 for vertical. We know A is going to be minus G. And our initial velocity, U, is going to be U sine alpha. And we know T is T. So if we put all that together, we're going to get minus 1.25 equals UT. So UT sine alpha minus half AT squared. So I have GT squared there. So those are my two equations. We've got this one here for horizontal and this one here for vertical. And we've got this one over here. So I want to try and find angle alpha. At the moment I've got 3 unknowns. I've got U, T and alpha. And if you look, both these equations have 3 unknowns. The equation over there has 2 unknowns. So the idea is if I can combine these two equations to get rid of T, the thing I get, I can then combine with the equation over there, which has no T in it anyway, to eliminate U and be left with alpha. So let's clear some space and give that a try. So let's write them up here, 20. Weird, can't write up there. I feel like my pen's breaking. That'd be good, wouldn't it? Yeah, give me a sec, guys. I'm going to see if I can fix the pen up with a new thing. Yeah, there we go. That's better. Cool. Lovely. Okay, so we got what was it? Minus 1.25 is ut sine alpha minus half gt squared. Cool. Let's get rid of all this stuff then. So I'm going to try and substitute the two big equations together to eliminate t. So I'm going to rearrange the first one to get t on its own and put it into the second one. So rearranging the first one leads me to t equals 20 over u cos alpha. I'm going to put that into the other one to get minus 1.25 equals u t, so u times 20 over u cos alpha times sine alpha minus half of g times t squared. So that's going to be 20 over u cos alpha all squared. Cool. Right, so some u's going to cancel. That u cancels with that u. We then get sine over cos, which is tan. So I can rewrite this as minus 1.25 equals 20 tan alpha minus 20 squared is going to be 400. 400 over 2 is going to be 200. So we get 200g over u squared cos squared alpha. So we've now got an equation that only has t and u in it. So if I combine that equation with the equation I started with, we can get rid of u and just be left with our alpha. So let's write it out one more time with everything put together. So minus 1.25 is 20 tan alpha minus 200g over, and we're going to put u squared in, so we get 2g over sine squared g, so sine squared alpha times by cos squared alpha. Okay, cos over sine is cos over sine is cot, and 1 over cot is tan. So that whole bit turns into 100 tan alpha. So minus 1.25 is 20 tan alpha minus 100 tan alpha. So if we solve this for alpha, we get tan alpha equals a quarter. And if we solve that, we get the alpha. Part B done. Part C, state a limitation that could affect your answer. Well, you could have stuff like air resistance, or the ball's not a particle, or the wind, or the spin of the ball through the air. So those are all things. Last bit, find the time taken from A to T. Okay, well, we know the angle now. So if we go back to our equation up here, and our equation down here, we're going to put alpha into this bottom one to find u, put u into the top one with alpha to find t. So if we do that, we get u squared equals 2g over sine of 14 all squared, which gives me u as 18.3. So we got U, we got alpha. Let's put it all together. So we're going to get 20 equals 18.3 t times cos of 14. So t is going to be 20 divided by 18.3 times cos 14. Cos 14. So t comes out as 1.13 seconds. Cool. Right, that was that took up the whole rest of the lecture. So did we finish it? Yeah, we finished it. Wow, look at that. Cool. We'll do something else on Friday. I better go because I've got another lecture right now. Make sure you're getting the assignments done, and otherwise I'll see you guys tomorrow. So see you then. Bye.